So all the solutions we've come to for our flows, both based on the Navier-Stokes equations and based on the Bernoulli equation, assume that the flow is what is called laminar, Laminar, and that comes from the Latin lamina, which means a thin sheet or a blade. And the reason it's called that is because the fluid is traveling essentially in flat, thin sheets of sort of constant velocity. So in the case of flow over a plate, the plate slows the flow down, so the velocity, the flow has to go up and over the plate, but it doesn't spin or rotate. It just, gradually shifts over. Flow around the cylinder, as we've studied it, is the same way. The flow kind of goes around the outside of the cylinder smoothly and, in smooth contours around the outside. But that's not always what flow does. When the inertial effects of the flow become greater than the stabilizing viscosity, you get a very different type of flow. So basically what happens is, inertia, which is flow, you can think of it as the fluid pushing from behind, pushing the fluid in front of it to go faster. But viscosity kind of slows everything down and keeps everything smooth and connected. But if you get a lot of speed, the thing will start to flip. And I always think of it like trying to push a spaghetti noodle. And so a spaghetti, you can think of the viscosity as how hard the noodle is. So when it's uncooked, the noodle is very stiff, and that would be a high viscosity situation. And as you cook the noodle, it becomes softer and softer. Now you think of pushing that noodle from behind. If the noodle is hard and has a lot of viscosity and you don't push it very hard, it will flow smoothly without bending or twisting. But if the noodle is somewhat more flexible and you push it slowly, you still might get it to slide along without too much twisting and bending. But if you push it hard and fast, it's gonna buckle and break. Even if it's really hard, if you push it hard enough from behind, it's gonna buckle and break. And that's what happens with turbulence. So in turbulent flow, when the flow gets really fast, the flow instead of, comes in, it starts out laminar, but then it starts to swirl and eddy, starts to spin out of control. Just like a car that's lost its traction, which is also a viscous effect. Traction is is a friction. So that's what happens. The flow starts to spin, and the flow above the plate will still be laminar because it doesn't encounter any obstacles. But the flow near the plate is going to start to spin and eddy. Similarly, if you look at flow around a cylinder, it approaches the cylinder perhaps in a nice laminar fast flow rate, but as it hits the cylinder, it starts to spin and churn. So you get this kind of churning and spinning in the wake of the cylinder. So that's what turbulent flow kind of looks like. It's a swirly mess. I'm going to try to bring in an example to show you in class. I'm not sure if it's going to work. But at any rate, this is turbulence. So turbulence occurs when the inertial effects of the flow become greater than the stabilizing influence of viscosity. The nature of turbulence is important to understand. Turbulence is always three-dimensional. It's always three-dimensional. As soon as that flow starts to turn and spin, it's going to spin in all three dimensions. It's not just going to spin in the XY plane. It's going to be completely out of control. Again, like a car that's gone completely out of control, spinning on a track, possibly flying into the air. So the whole thing is just out of control. It's going to spin in 3D. So there's no such thing really as two-dimensional turbulent flow, although we can approximate some things in 2D. But the flow truly is three-dimensional always. And also, turbulence is always unsteady. By the same argument, these swirls are never going to just stay in the same place. So there's no such thing really as steady turbulent flow. Turbulent in its reality, the swirls and spins are constantly moving and changing and going at different times and spinning to different places. So there's no steadiness to the flow no matter where you are. You're always going to see an unsteady type of motion. So that's the nature of turbulence. Now we need to talk about when we're actually going to experience it in flow.